series of videos as I attempt to finish off the work I've been doing on these OTL amplifiers. This is the second amplifier. This is the one that I swapped the capacitors on, and we've had some trouble starting up this amplifier. We've had trouble with blowing fuses, and we're not exactly sure why, so we're going to start this guy up again. And this time we're going to do it with no tubes in the circuit. So, first things, let's remove the tubes. Second thing is I have to get the fuses. Just excuse me a minute, I left them in another room. Hold on. Okay, sorry about that. Yeah, there's all the fuses. I have 6 of them, so I can afford to blow 4 of them. I'm doing this testing, although I'd rather not blow any of them. So we'll put one in and make a quick check, make sure power's off. Put in the fuse. Now, I've been discussing this with a few other technicians, and the one thought that comes to mind is that these big capacitors have been sitting around for a while. I don't know. Maybe they have been sitting around for years, for all I know. And they may need to be operated for quite a while to restore themselves. There's a word for it, I've just forgotten right now. I don't know much about that. I have a little bit of trouble believing it myself. But these are gigantic electrolytics, and I think reform the capacitors is what people like to say. So we're going to try and start this up with no tube load and see if our fuse doesn't hold in. Now, the behavior before was a little odd. 4 tubes in, fuse didn't blow, speaker protection open. 2 tubes in. After 45 seconds, when full power is applied to these capacitors, fuse blows. You would think if you take tubes out, it'd be less likely to happen, not more likely. So, I'm going to give this guy a go here. And I think I'll start here. Once again, you can watch these 2 meters. This lower meter, which is going to jump up in a moment. Let's watch it. There it goes. The lower meter I'm using to monitor the offset voltage. And the scale is 5 volts, so it's 2.5, 2.5, 0 in the middle. So it can swing out, in this range, something like that. But hopefully it stays in the middle. Now this meter up here is measuring the line voltage that's being supplied to the amp. Now, when it blew the fuse, I noticed the line voltage had been drawn down to 100 volts, which is really hard to understand. Unless there was a whopper of a drain. None of it's making too much sense to me right now. So, okay, so we're ready for this test. Let's see. Applying power. Okay, so you can see our line voltage is very high this morning. 24, 23 volts. That's quite high. Yeah. It varies, of course, from time to time and during the day. Okay, there's not much more we can do except give this thing a try. Okay, so here, switch on. Okay, do you see the small dip? The small dip is those big capacitors at charging. You see the dip went down and came up very quickly. So that tells you the charge was pretty quick. And it was done through a 5K resistor. Current voltage drain is it was down about 120, so it's hardly taking any power right now. I'm going to give it 45 seconds and the speaker protection should operate. There we go. And I heard the fuse blow. And you probably saw the meter jump up. At least I think I heard the fuse blow. I'm pretty sure I'll switch off. Yeah. Okay, so we got something seriously wrong here. There it is. The blown fuse. So that's 1 of 4. Well, something bad has gone wrong with this amp. And, oh boy. I've not got the best idea what that is. Man alive. Well, we better examine it very, very carefully, starting with aluminum shards and drill debris that I may not have cleared away properly. It could be sitting somewhere. I reckon it's not very likely, but let's take a look and see what we can find here. You know what, let's check for voltage on those capacitors, just in case there's 100 volts sitting there ready to send me through the roof. Okay, so this guy's got, yeah, he's got 130 volts sitting on him. And this guy, oh ho! This guy is 0. Let's check that again. $129 volts. So it looks like one, yeah, I think we're on our way to finding out what's gone wrong here. Well, let's get up. Okay, I know what's wrong. Shame, shame, shame on you, Jimmy. You've put a capacitor in backwards. Oh my God. Shame on me. Okay, I know exactly how that happened too. It's from flipping the lid, putting the capacitor and flipping it back and getting confused about which ends up. Basically. Well, the good news is that's easy to fix. So let's do that. Okay. It's a hassle, but shame on me. Okay, first we have to loosen off some of these connections that I made. Yeah, let's see if we can get a better seat here for this. Okay, I wouldn't want to. I'm using my tablet as my camera, and it takes up a fair bit of space, and it's pretty easy to knock it off onto the floor, and I don't want that to happen. Okay. Hopefully we didn't fry the anything else here. So we have to loosen these a little bit. Okay. A little more. I can't believe how stupid I was. The stupid part is I obviously did not double check after installing it. I checked it as I put it in, but I was actually wrong, and I was convincing myself I was right, and then blah blah blah. Shame on me for not double checking it. Okay. Hopefully no damage done. Certainly can't be sure of that though. Okay, we'll back out the extension bolts. Which I really do not want to do. I did not want to redo these connections. I was counting on getting it right from the start. Duh. Okay, those are loose. The amp is starting to pinch some wires in here. Who's getting the pinch? Oh. Okay. I just feel like an idiot, but mistakes do get made. Of course, I'm doing this on video, and the owner of this amp is going to watch this video because I'm going to let him, and he's going to see my mistake. Okay. Come on. Who's hanging on to it? Okay, hold on. Further mistake just made. Big bad mistake. Man, am I ever getting turned around here. Maybe I shouldn't be working so early in the morning. This is the one that's got to come out. This is where I'm making my mistake. I'm not getting enough sleep or something. I'd say I'm stupider and stupider. Okay. That's right. So the guy's okay. I didn't get him moved too far. You probably didn't notice, but I got a small shock off that. 100 and something volts DC there. Woke me up in the morning. Okay, so I was careful with this one. It's this one. Okay, Peter, I hope you won't kill me if I introduced him. Okay, so that looks to me to be turned around. Let's look under. Like that. This could be good news. This could be bad news. I don't know. Okay. Making sure everything's solid. Screw those guys back in. Oh, I just feel terrible, man. It's like the worst mistake I could have made. wait, before we screw these in, why don't I verify the positive and the negative here? That'd be a good idea. Try to repeat the stupid mistake. No, we have the positive and the positive. Oh boy. Get back over. How do you spell stupid? J-I-M. Yeah, good thing I'm not a space shuttle technician, eh? Okay. That's tight. You know what, just before I stick my finger in there, 0 volts. Well, hopefully my reputation for making mistakes will be balanced out by my reputation for being honest. Because I'm sure other people a little less scrupulous would come up with some story about what had happened here, would not admit the terrible, embarrassing truth. Difficulty here is I may have done some damage to the rectifier. Maybe not, because I suppose if I burned out the rectifier, then the next time I ran this test it wouldn't have popped the fuse, because it seemed to behave exactly the same each time. So. Okay. Exciting moments coming here when we're going to give this thing another try. Now these connections I'm making, they have lock washers in them, so they should not come loose. There would normally not be any heating in these connections, so you don't expect them to be thermally worked, from expansion and contraction. All these kinds of connections can be subjected to. These kind being bolted connections. Yeah, that's as solid as can be. Let's just double check the screw itself. Yep. Check the other one. Okay, I think we're ready to blow another fuse here. No, we're not going to blow the fuse this time. Should we put all the tubes in? Give it a full-blown test. Blown being the operative word there. Let us not do that. Let us start it up with no tubes. Get the to watch the excitement once again. Hope the capacitors don't blow up on account of my tablet camera is sitting right on top of them to get this shot. Okay, so switch is off on the unit. Power is applied. Supply voltage about 122. Should see a small dip on startup. No, I unplugged it here. Super duper safety. Let's plug it back in. Okay. Checking our meter connections. They're not made properly. See the offset meter going? There we are. Okay, so now we're ready to go. As far as I know, we'll never see an out, but here we go. That's a little unnerving. I didn't see a thing happen. And that's because I didn't put the new fuse in yet. So let's do that. There it is. Now the amp normally carries 8 amp fuses. These are 9 amp fuses. Two reasons for that. One, I had lots of 9 amp fuses because 9 amp fuses are never called for. So since these were available and there's no demand for them, I was able to get them. Really cheap. Okay. Extra amp won't make any difference in this circuitry. Here we go. Watch for the jump in the line voltage. There it was. Okay, that's how long it took these capacitors to charge through a 5K resistor. Now, I'm not sure about the operation of this amp. With no tubes in, the protection may not operate. So we gotta wait the 45 seconds to find out. This is where I should have a little song and dance routine, I guess, or some kind of entertainment. My cat has gone to sleep this morning. He's not down here helping out. There it goes. Wonderful. I did see another dip in the line voltage, which means there was another kick of current draw by the capacitors at that point. Very good. Fans going. Everything's good. Let's take a look at the voltages here. You can't see this, but I'm measuring the grid voltage. It's 56.8 on that side. 4. See, it's way out. It's way out. So let's bring it in. Camera here for fear of knocking it down. Put the voltmeter where you can see it. There it is. Get rid of that light. Okay, now we'll set up for this measurement here. Okay, so it was 56 and 47. The middle of that sounds like 51 to me, and that's... Oh. So there's the 55. We're going to knock that down with this adjustment. feels like it's at its limit. Jeepers. How about a screwdriver? That's going to do it. Okay. Okay, so we're 50 on this side. Oh, way too far. 52.5 on one side, 52.7 on the other. Okay, switch off. Install the first set of tubes here. I guess that's a strong indication that I didn't destroy the rectifier or do the capacitor any harm. And that's an attestation to the designer of this amp. So I think we'll just start with 2. So here we go. Watch the line voltage. You can't see it. You really need to watch that during the startup process here. And we're ready. You hit the switch. A more significant drop this time. And the reason for that is the heaters on these big tubes. These great big honking tubes. These actually have 4 heaters in them, each tube. 4 separate heaters. So I'm pretty sure this is 4 tubes in one. 4 of these, 16. So it's like having 16 tubes running. There we go. Beautiful. Now, if you saw this meter just pop a bit and come right back to the 0. That's wonderful. Protection fan is running. This will be the offset voltage now. 51.2, not the offset, there's a bias voltage. 51.2, 51. Beautiful. Switch off. Last 2 tubes in. Here we go again. Ready, set, and watching the line voltage. It's 120. Wow, do you see that kick all the way down to 110? And that's probably inrush current on 16 filaments. Plus, there's also 4 6N7s. Every one of those has 2 filaments. Not nearly the current draw of these big tubes, but nevertheless, that's a lot of filaments being operated in this thing. That's a total of 16 and 8 more. That's 24 tube filaments. Okay, keep your eye on. There we go. Fantastic. We have a fantastic result. That's excellent. Now I'm going to check the offset voltage with my more precise meter. My vacuum tube meter we've been watching, it's really pretty good. I keep it calibrated pretty good. one where you can see it. Okay. Now we'll read the offset voltage. 0.2 is a little high. It's jumping around. Where is that? My connection. See it moving? It's going down. And it's going down. The reason it's changing is the tubes are still heating up. I can feel the heat already. It takes a little while for the internal tube filaments to heat the actual glass globe up. So for a little while, you don't feel the real effect of this. Once these glass tubes get hot. Holy smokes. Now the owner of the amp tells me that he always operates it with the amp open. I might tell him to put a bigger fan on it than the cooling fan that's on here is certainly helpful, but it's not producing really the CFM you need. And part of the reason for that is you don't want to have one of these beautiful amps with a vacuum cleaner sounding fan running on it. It's got to be silent. So it has a very large fan. There it is there. And it blows right through this channel of glass. Yes. Well, that's great news. That's great news. I think we can declare this amp functioning. I really don't want to heat it all the way up. And I'm not going to put a signal through it. I've done that a number of times before, and it does amplify quite nicely. So at this point, I mean, what I really need to do is set these amps up, put them on my big speakers, you know, really put these amps to test. Maybe I'll do that in the very last stage, and we'll run my own speakers off it. That's great. Okay, I'm going to shut her down. Thanks a lot for watching. I finally have had some success after making a stupid error. Seems to have caused no damage. That's the good news from Jim's radio shop today. There you go, Peter. Amp number 2 fixed up and ready.